guys, today we're going to go over how to divide a fraction by a fraction. We're going to start off by connecting to a previous video I made, and that one was reciprocals, keep, change, flip. So we have our problem here, and it's 1/5 divided by 2/3. We're going to use the reciprocal. If you recall, that's the inverse fraction. So for example, here my reciprocal of 2/3 would become 3/2. We just flip it. Okay, so we're going to use keep, change, flip to solve this problem. Keep 1/5, change to multiplication, and then flip upside down, you might say, 2/3 into 3/2. So now we have 1/5 times 3/2. 1 times 3 is 3. 5 times 2 is 10. And that is our answer. One thing I want to emphasize is that you need to realize I'm going to start changing the symbol I use for multiplication now that you're in 6th grade, because from 6th grade on, we start using a different symbol if you haven't seen it yet. And that is we change from using the X to using a dot. And so you can also use the mnemonic device copy, dot, flip. We copy the first fraction, we change division to dot, and we flip 2/3 to make it 3/2. 1 times 3 is 3. 5 times 2 is 10. So now I'm going to show you a way to model what is going on so that it explains what happens when we do keep, change, flip. Because it's kind of like, well, okay, so that gives me the answer, but how did that work? So I'm going to draw a rectangle. And our first amount is 1/5. So I'm going to break it down into fifths. There we go. There's our fifths. And I'm going to divide it by 2/3. But the problem I have here is that I can't quite figure out how to get 2/3 because I'm dealing with fifths. So we're going to rely on our knowledge of finding equivalent fractions. We need to find a common denominator for each. Okay, so the least common multiple of 5 and 3 is 15. So what does that mean? I'm going to have to break this rectangle into 15 individual spots or sections. So I'm going to now make it 15 by breaking each of the fifths into 3. And I always like to count to make sure I didn't make a mistake. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yes. I'm also going to then convert this to equivalent fractions so that they both are 15. Okay, so this becomes 3/15 because I multiply 5 times 3 to get 15, 1 times 3 to get 3. And again, we're going into 15. I multiplied this by 5, so I'm going to multiply this by 5. 2 times 5 is 10. Okay, so I'm going to take 3/15. So that would be 1, 2, 3. I'm going to shade those in so I can see them. So now I'm going to take the 3 that is shaded, the 3/15, and divide it by 10. What does that mean? Well, now I'm going to count out by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is where I stop. I'm going to ignore everything after this. And to help me do that, I'm going to erase it. Now, how much is my fraction that's showing now? Well, it's 3/10. One thing that I want to emphasize is it changes slightly depending on which fraction is the greater fraction. In this first problem, we had 1/5 divided by 2/3. 2/3 is actually greater than 1/5. Now let me show you what happens when the first fraction is greater. So let's do 1/2 divided by 1/4. Okay. And now I'm going to divide it by 1/4. So since 2 is a factor of 4, I can just now break this big rectangle into fourths. And I'm going to stop at the greater fraction. In this case, it was 1/2 because 1/4 is smaller than 1/2. Now I'm going to count the shaded sections. 1, 2, over how many half sections? 1 or 2. So our answer is 2 for this problem. I realize this could be a little confusing, but I just wanted to model what's actually happening when you're doing the division. I highly recommend that you play around with it a little bit, but definitely the keep, change, flip, or the copy, dot, flip is your best bet to guarantee you get the right answer as long as your math is correct.